Hello everyone, I am Saishnu Manohar from CSCB presenting my concept video for chemistry. The topic I have selected is radioactive contamination in the environment. Let's begin. Let's get going with the introduction to radioactive contamination and its sources. Radioactive contamination is the presence of radioactive substances in the environment that can cause harm to living organisms. Natural sources of radioactivity include cosmic rays, naturally occurring radioactive elements in the Earth's crust, such as uranium and radon gas. Man-made sources of radioactivity include nuclear power plants, nuclear weapons, medical radiation, and industrial processes that produce or use radioactive materials. The radioactive decay process involves the emission of alpha, beta, or gamma radiation by unstable atomic nuclei. This is an example of the environment caused by radioactive contamination, and this is a symbol for area which is under radioactive decay. Types of radioactive contaminants. Alpha particles are heavy and slow moving and can be stopped by a sheet of paper or human skin. However, they can cause significant damage if inhaled or ingested. Beta particles are lighter and faster moving than alpha particles and can penetrate deeper into the body. They can be stopped by a few millimeters of aluminum or other metals. Gamma rays are electromagnetic waves that are highly penetrating and can travel long distances through the air or other materials. They require quick layers of concrete or lead to shield against them. The effects of different types of radiation on living organisms depend on their energy, the duration and dose of exposure, and the type of tissue being exposed. This example of alpha, beta, gamma rays and their penetration power to sheets of paper. As you can see, alpha rays cannot pass through a sheet of paper and they are slow moving. Beta can pass through a human skin but cannot pass through few sheets of aluminum. And gamma are so quick they can pass through entire body or and travel long distances in every vacuum. Environmental effects of radioactive contamination. Radioactive contamination can affect soil and water quality, as well as health of wildlife ecosystems. The decomposition of radioactive particles on soil and water surfaces can lead to long-term contamination and uptake by plants and animals. Radioactive contamination can affect the growth, development, and reproduction of plants and animals and can lead to reduced biodiversity and habitat loss. Environmental impacts can persist for many years after the initial contamination event and may require long-term monitoring and remediation efforts. Health effects of radioactive contamination. Acute health effects are those that occur after shortly after exposure to high levels of radiation and can include radiation sickness such as nausea, vomiting, diarrhea, fatigue, and heavy skin burns. Chronic health effects are those that can develop over a long period of time after exposure to low levels of radiation and can include an increased risk of cancer, genetic mutations, which is heavily harmful, and birth defects. Radiation can damage DNA and other cellular components, which can lead to mutations or cell death. The effects of radiation on living organisms depend on the type of amount of radiation, the duration and dose of exposure, and the age and health status of the exposed individual. Routes of exposure to radioactive contamination. Radioactive contamination can enter the body through inhalation, ingestion, or skin contact. Inhalation of radioactive particles can lead to a lung cancer and other respiratory diseases. Ingestion of contaminated food or water can lead to internal exposure and damage to internal organs. Skin contact with contaminated materials can lead to external exposure and radiation burns. Radiation protection and mitigation strategies. Radiation protection strategies include reducing exposure time, increasing distance from the source, and shielding against radiation with appropriate materials. Mitigation strategies for radioactive contamination include decontamination of surfaces, removal of contaminated soil and vegetation, and confinement or disposal of contaminated materials. Radioactive waste management is an important aspect of radiation protection and involves the safe storage of disposal of radioactive materials. Regulatory framework for radioactive contamination. National and international regulatory framework exists to ensure the safe use and management of radioactive materials. Regulatory bodies such as International Atomic Energy Agency, IAEA, and Nuclear Regulatory Commission, NRC, establish standards and guidelines for radiation protection and safety. Compliance with these regulations and standards is critical to prevent or minimize the risks associated with radioactive contamination. Monitoring and measurement of radioactive contamination. Radiation monitoring and measurement are essential for detecting and quantifying radioactive contamination in the environment. Monitoring can be conducted through air, water, soil, and food sampling and analysis. Radiological measurement techniques include gamma spectroscopy, alpha spectroscopy, and liquid scintillation counting. Future directions in radioactive contamination research. Ongoing research is focused on developing new technologies for detecting the mitigation radioactive contamination. Emerging areas of research include the use of nanotechnology and bioremediation to remove radioactive contaminants from the environment. Long-term monitoring and research is needed to fully understand the environmental and health impacts of radioactive contamination and to develop effective mitigation strategies. Let's go on to some examples where heavy radioactive disasters have happened in the world. Case study 1. We suppose the infamous Chernobyl disaster. The Chernobyl disaster was a catastrophic nuclear accident that occurred in the number 4 reactor of Chernobyl nuclear power plant in Ukraine in 1986. The disaster was caused by the combination of design flaws and operator error, leading to a stream of explosion and subsequent graphite fire that released large amounts of radioactive materials into the atmosphere. The disaster led to the evacuation of thousands of people and caused widespread contamination of air, water, and soil in the surrounding areas, as well as long-term health effects in exposed population. Here are some images of Chernobyl disaster, which has been a disgrace to human mankind and has been a ever-long biggest nuclear disaster ever happened in human history. Let's get on with the second nuclear disaster, which is case study 2, happened in Fukushima Daiichi nuclear disaster. The Fukushima Daiichi nuclear disaster was a series of equipment failures, nuclear meltdowns, and release of radioactive materials that occurred in Fukushima Daiichi nuclear power plant in Japan in 2011. The disaster was caused by a 9-magnitude earthquake and subsequent tsunami that damaged the power plant's cooling systems, leading the nuclear meltdowns and release of radioactive materials into the environment. The disaster led to the evacuation of thousands of people, caused widespread contamination of air, water, and soil in surrounding areas. Here is an image of the Fukushima Daiichi nuclear disaster. Now let's go along with the examples of radioactive contaminants. Common radioactive contaminants in the environment include radon, uranium, plutonium, and cesium. Radon is naturally occurring radioactive gas, which gets along with the noble gases section in the periodic table that can enter buildings and lead to indoor air contamination. Uranium and plutonium are radioactive elements that are used in nuclear weapons and nuclear power plants and can cause significant environmental and health impacts if released into the environment. Cesium-137, which is an isotope of its own, is a radioactive isotope that can be released during nuclear accidents and can contaminate heavily on especially soil, water, and food. Here is an extra information about radioactivity and ionizing radiation. As we can see here, radioactivity decay can be measured by the unit becquerel, which can be told as 1 becquerel is equal to 1 decay per second. And here is the ionizing radiation and the amount it's executing per radius, R, 2R, and 3R. Transmission factors include distance is based on inverse square law, actually calculated on inverse square law, scattering, absorption. Ionizing radiation strength from a point source decreases with the square of radiation distance it travels. This is the way of calculating it. The intervening medium can also absorb and scatter radiation. And here we use the instrument to decay radiation. This is a radiological instrument. The measurements quantities compose dose as gray GY, sievert SV, which are the measurement quantities, particle counts as per second CPS, and per minute CPM. Both dose and counts are used. Sorry. As we're talking about the dose, both dose and counts are used depending on the application and the radiation type. It varies upon every radiological instrument used in different nations across the world. Physical dose is measured in grays, is the measurement unit, and biological dose in sieverts, which is SIEVERTS, is also a measurement quantities for biological dose. Let's move on to the conclusion. We have come to the end of the presentation. Conclusion. Radioactive contamination is a serious environmental and public health concern that requires ongoing monitoring and mitigation efforts. Understanding the sources, impacts, and the mitigation strategies associated in the radioactive contamination is essential for ensuring public safety and environmental protection. Continued research and education are needed to address the challenges posed by radioactive contamination and to develop effective solutions for a safer and healthier future. References. My PPT has been taken, and I have taken the help of some of these references, which include United Nations Scientific Committee on the Effects of Atomic Radiation 2018, Sources, Effects and Risks of Ionizing Radiation, UNSCEAR 2017 Report, Volume 1, from the webpage United Nations. National Institute of Environmental Health Sciences, 2011, Radioactive Contamination. World Health Organization, 2011, Health Risks Assessment from the Nuclear Accident after 2011 is a Great East Japan earthquake and tsunami based on preliminary dose estimation. It's about the Fukushima Daiichi nuclear disaster. And the United States Environmental Protection Agency, which we talked before, US EPA 2021 Radiation Protection. Come to the end of the presentation. There's a small poster that I contribute so that we can stop radioactive pollution, save the planet. Thank you for your valuable time. This is Anishu Manohar presenting my concept video concept video on chemistry. Thank you.